I'm Mark Powler, co-founder and CEO of Insurgent Technologies Incorporated. We're preparing this video to give you an opportunity to learn more about how we got started and the various things that came about because of what we were trying to achieve based on what we found out, what we learned, and things we knew from the past. Where this all started really is back in November of 2015. My co-founder Isaac and I were at a medical technology event here in New York City. We're wandering around looking at all the various technologies, new ideas, demonstrations, and so forth. And I began telling Isaac about my first company, which was called Bioreactor Technology. And telling Isaac how back in 1983, when we got started, about a year in, we caught the attention of General Electric. And in 1985, Jack Welch approved a 10% equity stake in our company, which included a number of like 1,000 to 1,500 different man hours from GE's Corporate Research and Development Center, because we were located in Albany, New York. And it also came with a worldwide paid up exclusive license for something called the indium slide immunoassay. Now, this indium slide immunoassay, which we call ISI, was created by Dr. Ivor Giever, a Nobel Prize winning physicist in the 1970s. And once he had the patents that GE actually owned because Ivor was working for them, Ivor went out and started promoting it. He would go anywhere and everywhere to show people how amazing ISI was. He was a huge believer in it. It was a very simple type of test. And as I said, in 1985, we became then the licensee for that technology. So we began working with all sorts of different organizations, World Health Organization, Johns Hopkins, and everyone wanted something from us. The World Health Organization, for example, wanted a very simple test that they could use for detecting schistosomiasis, which currently back then about 300 million people were infected with each year. So they wanted something really simple. And the reason they liked the ISI was because it was a very simple test to actually use. And it was a visual test. You need kind of fancy equipment to actually be able to see the results. So we started working with them and received samples from all over the world and so forth. Then in 1987, a request came in from DuPont, who was working on the second generation HIV test, to come in and show them, ISI and so forth. So Ivor, along with one of his colleagues, Dr. Charlie Keyes, we all went, Charlie and myself, all went to DuPont to basically show them. Now, of course, Ivor had spoken with them to tell them about all the reagents he would need. We were going to bring the ISI slides for testing purposes. So when we got there, we had some conversations about the ISI, and then we were taken to a P3 lab where there was, of course, live AIDS virus serum. And of course, it was all the testing was done by a blind test. DuPont knew what all the various samples were. We had no idea what they were. We had to either tell them yes or no if it could be detected or not with the indium slide. So after about 90 minutes, where Ivor went ahead and actually prepared all the slides, then of course read them once everything was done. DuPont came back and told us that basically in the indium slide, or ISI, had far less false positives, far less false negatives, and a higher level of sensitivity than almost everything else they've ever seen. And they wanted to know, is this something that, of course, could be commercialized, and how we could go about doing it? Well, so here we are. We've got the World Health Organization asking, about this. We're talking to DuPont. There's other parties as well. And of course, there's problems with the ISI, okay? Because it's way before its time in terms of what it is and how it works, because it basically relies on solid state physics. Now, the two key problems really were that first, how could you scale this up? Okay, that was the first really big problem. And what Ivor had actually done was he went to a company in Santa Rosa, California, and had them make or tried to use vapor deposition onto plastic. And he had rolls of this plastic. Of course, it was tested, and it really didn't do very well. And normally the indium was placed onto a glass cover slip. Okay, but in order at that time, back in, again, the 1980s, to make millions of tests for the World Health Organization, millions of tests for DuPont and others, the cost would be through the roof. There's no way we could have done it in any reasonable fashion. We may have been able to do thousands at best. You'd have to have rooms full of physical vapor deposition machines running all the time, but it wasn't practical. It just wasn't. Anyway, so let's jump back here to November 2015. So I'm explaining about ISI and the problems to Isaac, and we start this conversation. We see people using smartphones, all those other devices, whatever, and as we continue to start talking about the problems and everything else, all of a sudden we start hitting on or coming up with these interesting ideas, all right? Where, hey, why can't we use a smartphone to read the indium slide? Wouldn't that make it much easier instead of people having to spend time learning how to read it properly? Okay, so we decided that maybe this is something that we should pursue and test and see if it works or not. Okay, so what we did next, of course, was we had to get in touch with Ivor and Charlie up in the Albany area and see if they had any indium slides lying around that we could use for testing purposes to see if the smartphone could actually do it. Because if it works, it can open up, immunology, or the ability to detect diseases and all sorts of things. Okay, and do it very simply and hopefully eventually inexpensively. So eventually we wound up, talking to them. They were going to try to find them. So at least we had that piece under control. The next problem, of course, became where we're going to get a wet lab. We need a wet lab to do the confirmation testing. Okay, so I went around to try to find, this is now December of 2015, find a wet lab here in New York City. And of course, with all the things that we needed for it, people were talking someplace between $15,000 to $20,000 a month, which quite frankly, we might need it for a year, 2 years at most. That would have been close to $480,000. We didn't have that money available. And we didn't believe any investor would give us money because we had no idea if we could make this work. We could find, not only get the reading part of it working, but the scalability. So I wandered into New York University, Department of Biology, asked if they had an immunologist, on staff, a professor, maybe some virology background, something like that. And sure enough, there was someone who had recently retired, who was, I guess, had an incredible reputation. And the folks at the office were kind enough to give me their name, this person's name, address, and phone number, and suggested I give them a call to talk about it, what we wanted to do. So as I wandered out of the building where the biology department was, right next door was actually this person's building. So I figured, I'm here. I went up, eventually got into this lab area because it had this lock on it, wandered around, and I eventually found the office of Dr. Carol Shulkis-Reese, and knocked on the door, introduced myself, and then I started explaining to her, what we were trying to do. And of course, she immediately was on, up on her computer, on the internet, looking at the various patents that, Ivor had or GE had, looking at a number of the publications that were out there. She understood who Ivor was and Charlie. And after about 90 minutes, she walked me into the lab area, pointed to a bench, and said, here, you can use that bench, for the confirmation tests that you need to do for ISI. So we have now a lab. And of course, this is near now the end of December, which means NYU is going on, Christmas break. And we need to order up all kinds of reagents, because the one thing that she would not supply us with, Carol was supplying us with, are reagents. That was our responsibility. So we had to order them up. So after the new year, we went ahead and ordered up our reagents. We had received the slides from Ivor and Charlie, and we went about trying to test them to see if they worked. And the simple fact is they didn't, because the last time those slides were made, the indium slides were made, were back in 1989. So we then went ahead and tried different methods of annealing to see if we could then activate them. And of course, that also did not work. So we tried different methods, went back into the lab to test, and it didn't work at all. So, at that point we realized we would need to get our own physical vapor deposition machine to be able to make the indium slides. So we went out and basically tried to price how much it would cost for us to get one. How expensive could it be? For the size that we needed, and of course it needed its own clean room and all these other things, it would cost roughly about $128,000 total, with all the pieces and everything else that would be necessary. So we realized we didn't have that kind of money to invest just in that one piece of equipment and all the infrastructure with it. So we then started looking, maybe some university or one of the colleges here or somebody had a physical vapor deposition machine that we could actually use. So wandered all over various universities, NYU, Columbia, whatever, and nobody seemed to have one. So I broadened the search instead of Manhattan, went into Brooklyn, and found at Tandem Engineering School that NYU had just basically gotten that, a professor was there working on some equipment, and I asked him if there was one available. He took me out into outside his lab, and they had this huge space, okay? And he said, look, if you come back in 8 months to a year, we're going to turn this giant space into a clean room, and we'll have physical vapor deposition, all these other things. You can come back and use it. Of course, I need it now. I need it right now. And he suggests I go up and see the people at CUNY in Manhattan at West 132nd Street, where they actually had a facility, a nanotechnology lab with the latest equipment. It was amazing. So anyway, I went up onto the internet, I found it, I then contacted the director to find out if I could get a meeting with him to see if, what equipment that they had that we might be able to use. Well, of course, they were still putting together, different parts of the lab, and no one had really been overly trained on it when I went up to visit with him. And he said, look, if you want to be able to use it, you got to go through all the special safety training, because there's all kinds of very dangerous things here. And of course, then training on the actual piece of equipment. So we're looking at someplace, I don't know, maybe a good 6 months. And of course, a learning curve to really work on this physical vapor deposition machine, which we really don't have any experience with. So I asked them, can you find a graduate student or a postdoc who could take care of this? And they said they would look for one. So, I left and, waited about a month. We haven't heard anything back. So I broadened my search further and found out that actually the Stevens Institute of Technology had such a device. And I went to meet with the director of this center, Micro Device Center is what they called it, and explained to them what we were doing. And they said, sure, they were more than happy to work with us, and assigned a postdoc and a graduate student who could do the work in terms of working with the physical vapor deposition machine they had. But keep in mind, they had a very old one. This wasn't like new technology, very old. So we met with everyone, and of course there were scheduling issues, whatever, but in the end, we had to supply the indium metal itself. We had to supply the boat that had to be used for the vapor deposition, and of course the glass cover slips. Anyway, so we got all that together, and instead of charging, and they only were going to charge $110 for each run, much obviously cheaper than the $128,000. So the run started, and by the end of, so that started towards the end of March, and we had maybe 8 or 9 runs where they made the slides. I would bring the slides over, then take them back to the lab, do the testing. Failure, 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 failure. Nothing worked. Ivor and Charlie were on the phone. We had conference calls with them because Ivor and Charlie both had made these slides, trying to figure out what was wrong, why it wasn't working. And eventually, around the 9th or 10th run, it worked. We actually were getting good results, actually decent results with the indium slide. So at that point, we felt comfortable enough that, okay, we would be able to then take these results, give them to Isaac, who was then going to basically come up with a classifier, some machine learning algorithm, to be able to read the contrasts, okay, and be able to tell the yes or no's. Meanwhile, you started looking at how could we do this using, of course, an app and the smartphone camera. All that has already been going on as we're now going through all these tests for the indium slide. Okay, so all that's in the works. Now, we can see we can actually make it. We can make enough of these. Isaac can test it for the classifiers and such. Okay, so we've got that under control. Next, scalability. This, of course, now became the real problem. How do you take a little glass slide that's maybe 3/8 of an inch by 3/8 of an inch, okay, and make millions of them, okay, and of great quality, better than what Stevens was actually doing? How can you do that? And of course, we're talking about just glass cover slips at this point. So we went looking around trying to figure out how we could, scale this thing. And luckily, we had a conversation again with Ivor and Charlie, and Charlie suggested that Corning might have something. And he wasn't really sure what the name of the product was, and spent then a couple days, going through Corning, talking to people there, and sure enough, they had something called Willow Glass. Willow Glass was invented in 2013, 2014. It's actually bendable glass. It comes in a roll, which means we could use a physical vapor deposition roll coater to make the indium slides. And we contacted this company out in California who sell the actual equipment, and they said, look, we'd be more than happy to do all of the work for you, so that we'll give you all the specifications. You can go to a number of different companies who have our equipment, and they'll make it for you, okay? And we'll do the work, and they would charge us between $3,000 or $4,000 a run. So, my God, that's fantastic. So, and this is incredibly sophisticated equipment. So we felt very comfortable that scalability could now be solved. But we had to check for sure, is this Willow Glass actually going to allow us to allow the indium slide to be made on it properly? So what we did was, of course, we asked Corning if they would send us samples, which they don't do that. They contacted some distributors, okay? And about a week after our conversations with them, we got this email giving us the names of 2 distributors who they had talked to, who would send us Willow Glass samples for us to test, okay, to see if we could, get the indium on it properly. So now, of course, we're talking towards the end of this is the end of July, beginning of August 2016. And now, of course, we receive the samples from these 2 distributors, take them over to Stevens, and of course, what happens? Failure, 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 failure. So we went through basically 4 failures in 4 different runs, okay? Cutting them into the size of the cover slips and so forth and so on. Failure. On the 5th try, we started to get some success. So it was clear to us, okay, that we could use the Willow Glass, and now we had the answer to scalability, okay? That now we could see that this would work. Well, around that time, this is now September, Isaac is taking a graduate degree course at Georgia Tech, and he has to come up with a project, in order to complete, the requirements for this course. So we're talking about things, and ultimately we realized that if these machine learning algorithms can read contrast, why can't they read color changes? And if we're going to use the smartphone to be able to read the indium slide, why can't we use the smartphone to basically read color changes as well? So we went out and got some glucose color test strips that came with its own chart, and gave that to Isaac, and he convinced 2 other people in his class to join him, and they created this software that, again, you could take a picture of the results and then hand it off to the software, and the software could then determine what the level of glucose was in a person's blood. Fantastic. So now we can see we can make this work. This whole concept of the smartphone, okay, visual results is what the indium slide is all about, and now by contrast. Now we can do this with color and it'll work. Now the question becomes, the procedure for the indium slide is one thing. The procedure for blood chemistry and so forth is something completely different. How do we package this into a usable product? Okay, how do you do that? I mean, how do you take all these various pieces and somehow pull them together? And that really started in December of 2016. And quite frankly, it was a mess. We used 3D modeling, 3D printing to try all sorts of designs. And quite frankly, just like with the indium slide, failure, 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 failure. Nothing was working. It's now, of course, we're now talking March of 2016. It looked like we were finished. But there was no way that we could somehow combine all of the restrictions, constraints, preparations, everything else, including FDA issues, into something that would be simple and easy to use. And quite frankly, we were on the verge of giving up because it didn't look like we were going to be able to find something. But sure enough, we did. We came up with this really interesting idea, or initially looked like an interesting idea. Then as time went on, it grew and grew and grew until it became what you can see in videos as our mobile, we call analyzer. And that helped us be able to see we have all the pieces. That would sit on a smartphone. We could then use it to go in to have the smartphone's camera be able to read, a cartridge that we came up with, and then of course send it over Wi-Fi, and then of course the back end could then do all of the work and come back with a yes or no or a particular number. That we had all of that in place. There'd be a lot of other problems that we had to deal with about how you make that all simple and get the apps working right, both from a mobile perspective, a web perspective, all of that, as well as EHR, EMR, LIMS, and a whole slew of other things like FHIR that we were looking at, as well as beyond simple types of tests, looking at hematology, so we could actually do red blood cell counts and many other things with this technology. So just to sort of refresh, where did we start? We started with proven technology that was too early. And then we found the answers of how it could be used today. And by finding those answers, it led us to seeing how what we were doing could be applied to a wide range of things, not just the indium slide, not just to the chemistry side, but a wide range of diagnostic capabilities. So just to be clear, all right, when you go to solve a problem and you find a solution, and many times that solution opens up doors you never thought were possible. And even though most of the things that we're doing even now, Isaac and I talked about them back to November of 2015. Think what we could do if we did this, if we got that working, what that would do, and what about this, and what about that? And what we're doing right now is manifesting all of those ideas into something that truly is remarkable. I'm Mark Powler. This is what Insurgent Technologies is all about. Thank you very much.